Okay, hello everybody. As you may know, the month of May has many the event for families, including Mother's Day and Children's Day and Parents' Day and Teachers' Days, and we all thanks to each other. Particularly for the parents and families. And I have noticed a couple of informations before to you, including one article at New York Times recently on computational thinking. This was reading, writing, arithmetic, and coding. This is a recent article. Copy. At New York Times. I informed you on this address because we applied for this computational thinking project recently. And we will have an answer in May. And what they were trying to say is actually in here. And computer science is big now and in the world. And if my kids aren't exposed to things like that, they could miss out on potential opportunities and careers. And this says some information, so the argument to reach the conclusions like that. And what we were doing was this. Okay, copy. And Chrome. I mentioned that you to take a look on this last night. Actually, I worked on the midnight yesterday to make this page for you. And this information, the concept of calculus, is based on the book Mathematics Form and Function by Saunders McLean that I translated it several years ago. Actually, it's more than 10 years ago. And Saunders McLean is a grandfather of my in my academics. So he was the advisor of my advisor, and one chapter of this is deal with the chapter 6 is on calculus, the concept of calculus, and this is where it was. Okay, calculus here, and I made it yesterday. So there are some things that to be checked before it's open to our student, but. I rewrote all the explanations and I added the necessary links and informations after I rewrote the statement. It includes the GeoGebra and SAGES and other related informations and images. And that may help our students. Okay. Okay, so, and also here, this is math and civilizations, and actually I have uploaded this many times You see, so we were successful with the civilization and math and civilizations, and it is working something like this. Here, 그러니까 이것도 저걸로 팝업 뚫게 해서 할 수 있지 않나? If you solve it, then you will make a fortune. It's $1 million is guaranteed. But not only the $1 million. Yeah, you don't have to teach from that, and you will take a position and do your research. Okay, and in this web address, then you will find those lectures that I have uploaded. Okay, and also that's a new version and which has other better features. So, and what else? And I have shown you. I have shown you. This movies on. These are about these from the mini bridges last year, and this year we will have real mathematical the structures in this bridge conference and the imaginary exhibitions. So and Mr. Lee Jae-yoon and Miss Yoon is making. Have already made, has almost finished their the smartphone application for math and art, which works okay. And then they will concentrate on this the web project on it. Okay. And random problems and others. And you must have uploaded what you like to say. So I will give you the time to talk about what you have done and what you are thinking. Okay.
Actually, I want to talk about projects. I revised my project. As you know, my project is about graph theory.
Great.
At first, I put definition of graph here and some translate to Korean just for title.
So you made it by yourself?
Yes, I did by myself, and show away check some sentence.
Good,
Yes.
very good.
But I don't know, right or no. Maybe. And we can run here something. And here is graph isomorphism, and this is translated to Korean. Please check if any wrong, please tell me. And here is isomorphism. Here is.
But when you get your help for Korean,
Yes.
have your mentor who is the native speaker.
Native Korean.
Because, for example, here the
Wrong.
graph 동영 is okay, but sub graph is not right. So we have 구분 graph.
Because we aren't Korean, yes, it's natural.
So it's okay, but there are very delicate differences which may cause a big difference. So when you can make a graph by yourself, but rather have the native speaker to just check it, then it will be much better. You will save a lot.
Yes. After translate, I put web address of these definitions, some books and some website like this. And here is subgraph. I put definition of subgraph and some comment in Sage. Vertex degree. I don't know this is right or no. And this is web address. This is right for vertex degree. Please check if it's wrong. Tell me. And
That's not right.
Okay, handshaking lemma and translate to Korean, and this is web address. Here we put theorem, handshaking lemma, and we check here, but I don't know why it doesn't work here. Size 2n. And we put definition for walk, trail, path, and circuit here, and here is the references, one book, graph theory, and vertex connectivity. This is translated to Korean, and here is address. This is definition for cut vertex, k vertex connected, vertex connectivity, or connectivity, so important in graph theory. And also we put some command for some special graph, for example, butterfly graph. You can see vertex connectivity is 1 for this graph. Means if we delete just one vertex, this graph will be disconnected. If you notice to vertex 4, if we delete this vertex, automatically delete 4 edges incident to 4 vertex 4, and after that just remain 2 edges. This means disconnected graph. Edge connectivity translate to Korean and web address, and some definition like vertex connectivity we have here and others. Again, for that graph, butterfly graph, we have edge connectivity and also minimum degree. Just we check this theorem. We have one theorem, relation between kg, k prime, and delta. Delta means minimum degree. This is edge connectivity, and this is vertex connectivity. For this graph, we can check this is right, because 1 less than 2, 2 less than or equal to 2. Always this is right, and this is just one example. And it's definition of gears and circumference. Connected and disconnected graph translate to Korean here and website. We have definition of connected and disconnected graph here. This is one graph. By Sage, we can check any graph is connected or disconnected, like this graph. And another concept in graph theory is distance, and translate is this. Please check again. And we have some concept for this part: distance, eccentricity, radius, diameter, Wiener index. All needs distance concept we have here. And for example, for this graph, a star graph, we checked by Sage radius, diameter, and Wiener index. And at first is eccentricity. For all vertices, we have eccentricity. And after radius is 1, diameter is 2, and Wiener index is 100. But by hand, not easy for some special graph, but by Sage is so easy, like this. And this is one code making by myself, finding maximum Wiener index among trees. Just by Sage, we can test this kind of exam. By MATLAB or some other program maybe it's possible, but longer than this. Okay, after checking in all trees with 15 vertices, we found which graph has maximum Wiener index. This graph has maximum Wiener index, and Wiener is equal to exactly 380. And after that, vertex coloring, and I put definition of vertex coloring. And for this graph, we can see chromatic number of graph is 2. Why? Because how we can color vertices with different color? Just with 2 color, we can color this picture. Why? Suppose this is red and this is blue, blue, blue. Just adjacent vertices can't have same colors. And edge coloring, some special graph I put here. And after a special graph, I put some here, like Peterson graph, and some kind of graph here. And I found this code in this web address, and by this code we can make any graph. For example, this graph, And many graphs we can make. Like this. Some huge graph and some graph is a small graph. And Eulerian, Hamiltonian, matrix representation of graphs, just about matrix, and this is related to matrix theory. About adjacency matrix, I told in class, but I put just here definition.
Yeah, okay. Okay.
And after this Laplacian matrix, I put definition here and use Sage program.
So you will give definitions and some explanation and some code and you will refer where you got those information.
Actually, almost all I use just one address, and I put in first of all. I put that web address. But if you need, I can put. But all is same. Why again I have to repeat?
But anyway, the one you have to give a credit who made all this. So wherever. So
I have to put for all place.
No, not all. But at least these are the things that you did not make. Then somewhere here and there, and you can add. You better add where you refer to those information. And also, go through it. You will go through the concept of this characteristic
Polynomial of graphs, yes, and a spectrum of a graph, yes, and some command here and finish.
Okay, good. As you have seen, and Mojallar have made pretty much of progress. He tried to add the Korean explanation, so our student can have a benefit of it. And also, he referred the web address that he used it. And also, you may give some acknowledgement that you better give it, not only just one of this web address. And also he used the code to explain to give a visual explanation of this, and he added many different concepts. But still, there are many things to be checked. Particularly, Mr. Kwon will give native speakers check on the translation of the terminology. This must be 부분 graph, not subgraph. And also, I see these graphs are okay, but I wish to see some more of your ideas, not just copy this definition from where and just copy this command from there and just adding things. And over that, I wish to see your contribution. Some of why this is interesting and your lines to support these definitions, and categorizing those concepts, chapter section 1, section 2 with these so some terminology, basic terminology, and advanced, all in one page or separate? It's up to you. Yeah, you may use about three pages as a very simple introduction of the basic terminologies and example, and little advanced ones, and some applications and something like that. So 3 pages and link, and that will be much better. And then after that, you can make a 1 page of the. I will help you to make a 1 page that makes all the connection to all those 3 pages to explain. And then we can make a smartphone application, the cover page, to connect that page to each of those 3 subjects that you are trying. Then yours will be quite okay. Kind of thing. Yeah. Mm-hmm. If you do it, and then that will be very fine. Okay. Anyway, others have seen that, and you may add your comment to improve this. And I have something to show. If you go to this page. This is the one that I have made already. It's long ago. It's about more than 10 years ago. When I teach discrete math. You may refer some of this website, the Mozilla, because it has the information on the definition of what you are learning from discrete math at the university level, and it has all these Java applets, and including this update가 필요한가 지금? Okay. So 건조교가 이거를 이거 지금 해야 되니? 자바 업데이트를 해야 되니?
지금 안 하시는 게 좋습니다.
안 하는 게 좋아? 그럼 프레시만 보여줄게요. For example, this is about Catalan numbers and the things, and this is about the counting numbers, the relationship between Catalan number and this, and this is Brahma's Tower of Hanoi. And what? This is the 육각수를 영어로 뭐라 그러나? How is this? 육각수 number. 그러니까 number of is what? 6. What octagon? No. How they call? No? Hexagon. Yeah, this is the hexagon number 3 number system. This is what? The golden ratio. This is about this is complete graphs. How it makes it, and this is about Pythagorean theorems. This is a kind of visual proof of the Pythagorean theorems. And this is planar graph. This is another proof of the Pythagorean theorems. And this is the number of the squares. And these are all. And Fibonacci. This is about. There are Fibonacci's. There are things that I have already shown, and also 나중에 하지 뭐. 근데 이게 자바로 다 만든 건데 이제 만든 지 오래돼서 이제 업데이트를 해야 될 필요가 생긴 거예요. 왜 안 가? 뒤로 왜 안 가? 무시. 오케이. And on chapter 시범 강의에서는 이 챕터 1장에서는 1장 소개를 하면 1장의 강의 소개하면 강의 그럼 질문 terminology here. Actually this is what I wanted to show you. This is the terminology for the discrete math. So if you refer this is actually what what we already have. But so you better use it. you better use it. And and terminologies and freshest and applets. Anyway, and there are some more, but I will. So anyway, there are the things that we Songyungan University already have developed, and our students have had the benefit out of it. You have to start from there to improve it as much as you can, not from the beginning. Okay. And next, who's gonna talk next? Shall we? Yeah, you can. Or Mr. Kwon, or Mr. Lee. 자, Mr. Lee. Okay. 그거 갔다 와요. Okay, the Victoria, then you may show it first, then the Shinshao will do. Okay. You may talk about your knapsack.
Okay, so I will just give a very short explanation of this. So this is the last part that I'm doing or developing for the application, I think. So the last thing I'm going to do now is just finish organizing everything. But I really wanted a way to, I wanted a way to put weapons into the app, like in order to account for weapons that people may use when they fight zombies. And that was a little hard to do with just the differential equations. So in order to mathematically add them, I thought about the knapsack problem, which the knapsack problem is given here. Hold on. Yeah, so the problem is basically you want to optimize if you have items of a certain weight and a certain usefulness, something is useful or something weighs more. You want to find the optimum configuration such that you have the maximization of weight with the usefulness of the item. So this is a very, very famous problem. But anyway, so what you can do with what I developed, the tool that I made here. So basically, if you put in order to calculate usefulness, I used the video game that the weapons are from, and they actually give you for any particular weapon, you can see the damage that the weapon gives within the game. So I had the damage per second count as the usefulness of an item, and then for the weight, I just went on Amazon and looked at average values of weight for weapons like chainsaws and cool things like that. But anyway, I'm not finished. This is just a start to this. But so anyway, using here what I made here, if you put your weight, so the weapons that I added so far are just a golf club and a pistol, which is like a small gun that's very light. And you have a hunting rifle, which is a little more heavy but more effective. Then you have a chainsaw, which is really, really effective and really, really heavy. But you have to fight zombies with a chainsaw. But anyway, so what it optimizes based on your weight. So for example, if I put this is my weight, but if I put my weight, then it will tell me, okay, well, you have a golf club and a hunting rifle. But if you weigh 60 kilograms, this is in kilograms too, but I will fix that later. Then it will tell you, okay, well, you can have a golf club, a pistol, and a hunting rifle. Or if you're 45, really small person, then a pistol and hunting rifle. So basically, based on your weight, it can solve or it can choose the best weapon choice for you. But yeah, so I wanted to continue to just put that at the end and then organize everything for my application, and that's it.
Any questions or comments?
Yeah, hello everyone. Yeah, last time the Kyungwon Kim have uploaded something about how to develop the applications of Android mobiles, and so I followed it, and also Victoria have made some beautiful applications with beautiful background, pictures with of the RMPG, and I also re-edited it and make one like this. So you can see here. I just re-added the layout and add the links of the each topics, and the similar concepts as the PC versions. So, yeah, that's all similar. Just changes the layout and.
So what was the changes? What was the changes that you made?
First, that's so the main page I changed the user. Last time I left the website, I used the link, re-edited the website and use it to our RMPG. Yeah.
Who were involved to make this? This page I made by myself, and the APK is made by Kyungwon Kim, and also the, others like Victoria also makes the old version. Yeah, so I changed it from that. Yeah, actually I made it from the last one I have. Where's my name? Yeah. Actually, I just used this page to make our applications. Yeah, you can see. Yeah, I delete the file. Sorry. Yeah, that's all I want to tell you. Yeah, thank you.
네, 안녕하세요. 이명준입니다. 먼저 공학수학을 세이지로 구현하는 것들을 해놓은 것들을 우선 지금 다 모아서 이제 1기미분 방정식에 대한 것들을 다 모아서 이제 정리를 좀 해봤는데요. 먼저 여러 가지 교재에 있는 내용들을 조금 모아놨기 때문에 좀 내용들이 약간 섞여서 조금 중복되는 부분도 있긴 한데 결국에는 이제 많은 컨텐츠를 좀 담으려고 하다 보니까 그렇게 됐습니다. 먼저 1기미분 방정식에서는 그 내용들이 분리 가능한 상미분 방정식과 이제 다른 컨텐츠들이 나오는데 이 교재가 있는데 이 교재에 있는 내용들에 대해서 먼저 간단한 이미 나와 있는 코드들도 넣었고 그 코드에 대해서 이제 내용 코드 그래서 지금 미분 방정식을 이제 앞부분부터 계속 정리를 해서 모으고 있고요. 그리고 여기 부분들은 이제 계속 번역도 되고 코드도 수정이 돼서 조금 진행이 되어야 될 것 같은데 먼저는 우선 진도부터 쭉 나가서 PDE까지 먼저 일단락 하는 게 좋을 것 같다고 생각이 듭니다. 그래서 초역관 문제도 이런 식으로 다 넣어주고 그거에 대해서 그리는 것까지 이런 형태로 다 넣고 그리고 다른 운동 시스템계에 대한 것들도 있기 때문에 그런 거에 대해서도 코드들이 있어서 코드들도 다 넣어서 진행해보고 있습니다. 그래서 이런 식으로 계속 정리가 될 거고요. 네. 그리고 활용되는 부분도 있어서 우리가 매트릭스 랩에 활용되는 부분들이 있어서 링크도 연결해 놓고 같이 응용되는 부분을 확인할 수 있도록 연결을 해 놓았습니다. 그리고 마무리 조금 하면요. 편미분 방정식도 이런 식으로 코드를 모아서 지금 진행을 하고 있고 저뿐만 아니라 권영욱하고도 같이 이런 식으로 지금 댓글을 달았는데 권영욱하고도 이런 것처럼
뭐 했어? 건조기는 어떤 거 해봤어? 시험막하고 그리고 뭐가 안 된다고 쓰고 쭉쭉쭉 넘어가.
네, 이상입니다.
Stop. So we may quit here today. But I have made this. This is one. This is a mathematical moment, and I downloaded all of this, and Shun Xiaowei helped me to find this. So, and I made it as a one paper, one file of this 107 the piece of the applications of mathematics. And now I have made this JPEG files of 107 applications of mathematics. I wanted to make a kind of movie to show the animation of all those, and then you can use it. 그래서 107개 되는 어플리케이션 다 찾아보기도 힘들고 하잖아. 그래서 다운로드 타기도 그렇고. 그러니까 오히려 이거를 그냥 동영상으로 쭉 지나가면서 보게 하면은 아 수학이 이렇게應用되구나 하게 되겠지. 그럼 파밍 코드 같은 데 쉽게 만들 수 있지 않아? 이미지를 집어넣어서. 내가 파일 줄 테니까 누구 할 수 있는 사람 있으면 하고 싶은 사람이 있으면 와. 이거 다운 받는 것도 힘들다. 107개 받으려면 이거. Okay, so time's up. So yeah, we will finish up today's class. Okay, thank you for your work and enjoy